Hey everyone, thank you for joining me here. So let's take a look at the connection between a definite integral and Riemann sum. So here is a theorem that is stated in a calculus book, and we'll be converting this definite integral into Riemann sums using the right endpoints rule. So how do we do that, right? So we'll take a look at the theorem. So assuming f is an integrable function, on this interval, then the definite integral from a to b of f of x respect to x is the limit as n goes to infinity of the sum starting from I equals 1 to n, well, letting n go to infinity, f of xi d delta x. So that is the translation of a definite integral to the Riemann sum. We take the limit of the Riemann sum, of course. Now, how do we find these pieces? Well, you compute delta x as b minus a over n, so that is your interval. And then xi, that is like the ith endpoint on the interval, that is a, which is the first point on the interval, plus I delta x. All right, so let's do that. Let's do that for this example. The first thing we're going to do is figure out our interval. The interval is right here. That's the limit of your integration. So our interval for this problem is from 4 to 6. So consider 4 is your A value and 6 is your B value. All right, now the function is this piece right here. That is your function. So you can call it f of x will simply be considered to be the square root of 3 plus x squared. So we need to compute two things in order to write this integral as an equivalent limit of the Riemann sum. So we know this is the limit as n goes to infinity of the sum I equals 1 to n of some f of xi delta x. So I know f of x is this, so I need to compute xi and delta x to substitute them. So from this formula above, as we can see, xi is given by this formula. So we know our xi should be a plus I delta x. And we know delta x has to be b minus a over n. So n as many rectangles as you want under this curve. Again, we're not going to evaluate, so we're not going to need to think about that at the moment. So let's substitute. B is 6, a is 4, divided by n. So that will be 6 minus 4. That's 2 over n. So our substitution for delta x is 2 over n. Now xi, well, that's going to be a. Like we said, a is 4. So this is going to be 4 plus I delta x, so times 2 over n. So you could just write this as 4 plus 2I over n. So that is our replacement for xi. Okay, so let's go ahead and make the substitution. So we're going to substitute xi in place of x in the formula, and then delta x, we're going to substitute 2 over n. So let's go ahead and do that. So we know our definite integral is to rewrite the problem from 4 to 6 of the square root of 3 plus x squared dx. This is equal to the limit as n approaches infinity of the sum starting from 1 to n of f. Well, f here is the square root. So this will be square root of 3 plus x, we replace it with xi, which is this box we just computed. So that'll be 4 plus 2I over n squared. All of that is under the square root times delta x, which is 2 over n. Now, to protect everything, make sure you have parentheses around. So just like that. So you can just decorate this. This will be times 2 over n. There you have it. So this is what we call expressing a definite integral as a limit of the Riemann sum. That will be your final answer. All right, I hope this makes sense. Don't forget to subscribe and like. I will see you next time. Take care, everyone.